Okay, so this is Plenty Gorge Road, and as you can see, it's not much outcrop. It's very noisy as well because there's a lot of bridge. So in this geological video, as you can see, you can't see any outcrop. Pretty much probably over there, that's probably the Dargo Formation that you can see, and on this side of the river is as well. But if you go up there, so I have made a video up from a higher elevations about this. So if you go up over the hill, you get to the Anderson Creek. So it's a bit confusing because over the time these details of these formations have changed, and we don't keep them up to date quite as much as probably some other localities. So sometimes they describe the Dargile Formation as not having fossils, sometimes they describe it as having abundant fossils. So in most likely in different localities is that they have different fossil abundance. So we don't know. So here we have the Dargile Formation. And so this is a mudstone. As you can see, it's been fractured. So here's a fracture that goes across there. Another fracture as well, and in the fracture water is seeped and deposited, probably iron, so you get iron inclusions, and these are quite hard. So this rock here is soft. I can scratch it with my nail. This is soft, but this part here is hard. So as you can see, the laminations, and this is the soil you get from the actual rock. And also up in the high elevations you get basalt. So here's laminations. So as you can see, so if you're not too sure, the strike and dip is about that way, so it's going into the actual hillside, and so you can see the strike and dip is going that way. Probably, what's the angle? So 45 degrees will be that way. It's probably like 55, 60 degrees. So it's quite a steep. So this has been caused by being compressed because of orogeny. So the Tabaranian mountain building process. So the two rocks have been squeezed in together and they form anticlines and synclines. So this is the limb of an anticline or a syncline. I don't see any anticline synclines. And if we go down into the creek, I don't have a microphone. You can see all these chunks have actually fallen off. Flowers. So it's probably been eroded from that formation and fallen down into the actual river. But as you can see, they're quite large. So this is the Dargo Formation. I doubt it very much you'll find fossils here, but you can try breaking open this rock. So the surface of it will be a bit eroded. And this is Silurian, about 400 million years ago, roughly. As you can see, you can find quite a lot of this rock in the water. And also they've built a bridge just over there, so they would have had to have excavated some of the rock. Some of this rock has probably just been placed there after the excavation, because if we go up to river, you don't get much of these large chunks of rock. So I reckon this rock is not naturally put here for the most part. I reckon some of it's been put here by coming down off the side. Some of it's probably been moved, excavated out, then just dumped over here. So there's not really much else to say. So this looks all pretty much like mudstone. You can get sandstones in here. You do get some inclusions And as you can see, it's strike and dipper. This one's that way. So it's been exposed to the surface for quite a long time. And if we go up here, and this is pretty eroded. Okay, you can probably go along here and find other formations, but I won't. But as you can see, it's been thoroughly fractured by being compressed, and then looks like iron oxide's been intruded, probably precipitated by water. This would have been at depth, probably 5 to 10 kilometers, I'd say. Could be deeper, but I don't see any quartz formations, which means it probably isn't deeper. Usually you get quartz in the lower formations, which are place deposits for gold. So this is very eroded. So this has been sitting at the surface probably hundreds of thousands of years, because this river system is probably quite old. I'd say this river has been flowing for quite a few million years. The basalt that is up that way was deposited about 2 million years ago, and so this river is older. So if the Tabaranian orogeny was about probably around Devonian, I believe, about 380 million years ago, 350. And after that we had the Permian glaciation of this area. So this river could be at least 350 million years, probably not, but I wouldn't be surprised if it's like 50 or 60 million years. That's how old this river system is. And see, here we have basalt. It's probably been taken by somewhere at a quarry, and it's been used to shore up the side of the hillside. Yeah, there's concrete. So in a few million years, that's going to be quite a common rock. Yeah, I'd say. And this doesn't want to turn. Okay, I think my gimbal died because I didn't charge it. Anyway, here's where I leave the video. I hope this helps you with your just looking for fossils, looking for rocks, looking for gemstones. Just get a geological map, just go outside and enjoy it. So as I'm walking up the hillside, you can see the river system down there, and another part of the Dargo Formation, pretty weathered, but as you can see, you get high up. So the Dargo Formation's pretty much that hill there. I mean the Anderson Creek Formation's that hill. Dargo Formation's the lower slopes. And you can see all the regolith and soil. So the soil has a lot of organics, regolith does not. So pretty much up there we have the major exposure, the Anderson Creek. So here's the tail end of the exposure. So we have like a S shape going there, so it's S going around. So that is here the actual strike and dip. Oh, look at these cars. Probably about 45 degrees, but as you get this way it gets more towards 80, 70 degrees. And as you can see over here, this is a very busy road, but it's a good road to see the exposure. As you can see, it gets more deformed as you get that way, nearly towards 90 degrees, so it's nearly exposed, folded that way. So this is the Dargo Formation, and just up above that hill is where the basalt starts. And it's very distinct. The basalt just stops instantly. So there might be fossils in that, I'm not too sure. But it's a nice formation to see. So anyway. A nice piece of mudstone. As you can see, it's very fine bedded. Should also be easy to scratch. Yeah, so there you go. Scratch it with your fingernails. So the mons is lower than 2.5. And just be careful when you are walking down here, because you can actually fall down that cliff down there. It's pretty much a cliff. So all this soil is derived from this mudstone. So it has a lot of clay in it. That's what mudstone is, it's just made out of clay pretty much. You might have some small feldspars and silicon, but because it's so dark, you need to do a mineralogical test to know what the formation's made out of. But mudstone, you know, usually comes from igneous rock, probably like a granodiorite or a basalt that has a lot of clays in it. And that's why the waters here are quite dark, because it does have a lot of clay suspended in the actual water, which makes it quite dark. And here we go, you can see this is probably a very eroded and weathered formation. You can see some smaller parts. This might be actually a sandstone. Actually, probably a siltstone, I'd say. Silt-sized particles. You can see different. So this more looks like a sandstone there. So, how would the sandstone get in here? Well, you got continental slopes, and they dip probably I can't remember, 2 to 3 degrees. So, and sometimes they dip like 45 degrees at the end. And sometimes the sand builds up on the top, or a current pushes sand down. It just goes down the slope. So you've got turbidite formations, and that's how you get larger rocks, because mostly on the sea floor, continental bottom, you need some type of energy, because it's a low energy environment. So you need a lot more energy coming from the continental shelf to push larger rocks down a continental slope into the deep ocean floor. And that's what we have here. Anyway, this is a nice park. So it's a pretty concept actually, no? There you go. Still not used to my gimbal. These things are a bit hard to handle too much, and this one doesn't behave properly, so sometimes it just goes crazy. I think it's got a mind of its own. Maybe it's an AI, artificial intelligence that has sentience. Anyway, this is the end of the video. Thank you for watching. Hope you can go out and enjoy some geological formations.